let's take a look at the fifth lesson here on distributions. We're going to be creating visualizations which allow us to understand the range of behavior in a data set. If we get this Kaggle notebook up and running in our own accounts, the first thing, of course, as usual, is to set up the first chunk of code which loads our different libraries. In this case, we're going to be looking at sort of a famous data set that's all about flowers, irises specifically, and the being able to understand and visualize the differences between different types of versions or breeds or species of irises. This data set is used pretty often for machine learning tutorials and in this case, visualization tutorials. It has a data set of 150 different flowers, 50 from 3 types of species. You can see those 3 species here. And there are different attributes about these species in order for us to be able to try to identify which species is which according to the characteristics of the data. If we load that data set, what we'll see here is the first 5 rows, sepal length, sepal width, petal width, and then the species itself. So you have different measurements in centimeters for each of these 4 characteristics of irises, and then the species itself. Distributions of data really are meant to show how something behaves over a whole bunch of samples that are supposed to be similar or the same thing, but in reality aren't. So in these particular group of flowers, you can see that the petal length in cms across all 3 of the species types, you have this sort of behavior, this distribution of behavior. Between 1 and 2 centimeters, you've got this many samples. Between 2 and 3, you have this many samples, etc. And we're using what's called the histogram. In Seaborn, you can use what's called a dist plot. Distribution plot allows you to see the number of different, sort of bins the different attributes according to this particular measurement. And in this section, it's teaching you, okay, so A is the column that you want to do the distribution plot in. False for KDE, which we'll talk about in a second, which will create a different plot, which we'll look at here in a second. A density plot is the same thing, except it is using a more smoothed histogram to show the area under the curve is more smooth. It's not quite as jagged when it comes to that as compared to the histogram. So here you can see there's 2 sort of modes here of petal length in cm, at least 2, which is very prominently showing that there are two different like types of flowers potentially based on their petal length. We have 2 humps here, which shows that there's 2 spikes in data in that case. We can use 2-dimensional KDE plots in terms of just using only maybe petal length. We can also use sepal width to show that there's like a bimodal situation here with the petal length. And then there's a single distribution here for sepal width. Let's say we want to start looking at the different species. We create plots which try to visualize what we're seeing in the different species. And so in this case, we are reading in 3 different files from the 3 different species. We put them in their own data frames through a read CSV. We're going to look at the first 5 rows of one of the species data sets. And you can see that it's similar in the way that it's set up. When we go ahead and plot 3 different histograms for the 3 different species with different colors, what's going to happen is you're going to see a situation where you're starting to see the differences. So according to petal lengths, Iris setosa has a much smaller petal length as opposed to versicolor and virginica. And even they have a little bit of overlap, but there's differences there. Let's say we want to look at the distribution using the KDE plot, which is going to be a more smooth distribution, which is going to give you an understanding of this very strong differentiation between the species Iris setosa versus the other 2 species. So there's a coding exercise which can kind of help you look at the difference between these types of distribution plots to help solidify your knowledge.